All right, this is section 6.1, functions and systems of equations in two variables. I'm going to leave part 1 for class. I'm going to go on to part 2, solutions of systems. Let's focus here a little bit. So there's 3 ways to find solutions, 3 ways. One is by graphing. Let me start first. The systems are going to be linear systems, which means when we graph them, they're lines. Okay, or you can also look at the exponents on the variables and 2 variables with exponents 1. All right. So there's 3 ways to solve. One, we can graph the system. Notice each equation is a line, so we're going to have 2 lines graphed. And then we can find the points of intersection, and the points of intersection are your solutions. So here's 3 different possibilities. Okay, so I graph this system, and the solutions are the points of intersection, but I don't see any points of intersection. What's going on? Well, they look like the lines are parallel, which means they're not going to touch. But are they really parallel? Well, if you look at the slopes, they're the same slope, so yes, they are parallel. And so therefore, they're not going to touch, so I'm not going to find any solutions. So my answer then is no solution. Okay? Your book might write that as the solution set that has no solutions, right? An empty set. Okay. The second possibility is they do cross at a point, and if that's the case, then the point where they cross is the solution. This point, the point of intersection, is 1, 2. So my solution is the point 1, 2. Notice we've seen something that looks like this before, but we were not solving systems, and so therefore we only answered x equals. But because we're solving systems, we need to indicate the point where they intersect, which is made up of x, comma, y. Okay? All right. And then finally, it's possible that the 2 lines both result in the same graph. That means one of your lines overlaps the other one, right? It's lying on top of the other one. And so they intersect at every point. Well, how do we say all those solutions? Well, there's infinitely many, so we answer infinitely many solutions. All right, now, there's a way of writing this. We don't have to use it, but your book might have it, and it's called parametrized. And what that means is that they write one variable in terms of the other. How do they do that? Well, you take one of your equations and you solve for y. Let's take the first one. So we take the first one. This would be y equals negative x plus 5. And then you write your solutions this way. X, comma, and then y, instead of writing y, you write negative x plus 5. What does this do? Well, it allows you to generate any number of solutions that you want for any value of x. Notice if I just pick a value of x, like 1, y will be negative 1 plus 5. If I pick x equals 7, y will be negative 7 plus 5, and so on and so forth. There, I can generate all the different solutions that I want to generate. All right. So those are the 3 possibilities when you see graphs. But they kind of have drawbacks. One is you have to spend your time graphing. That means you got to have a grid that's precise. And then 2, what happens if your lines intersect at a point that's not one of the little corners on the grid and you can't tell where they intersect, right? You can see that they intersect, but you can't tell what the coordinates of the point are. So there's 2 algebraic ways. One is elimination, and the other one is called substitution. Elimination works this way. We multiply either or both equations so that adding the x terms or the y terms, whichever one we see or we like, from the 2 equations results in 0. So we're going to add them and they're going to add up to 0. Then add the 2 equations. Again, when we add them, either the x terms add up to 0 or the y terms add up to 0 from the 2 equations. Let's try that here. So there's a couple of little details we need to keep in mind. One is we want to line up the equals and the y's and the x's. Okay, so these are lined up. Okay, so what we want then is, if it's not done already, we want to multiply either one or both equations. So when we add either the y's or the x's, those add up to 0. Well, if I just had a negative y on the bottom or on top, when I add y plus negative y, that would be 0. So what I'm going to do is multiply the bottom equation by negative 1. I multiply by negative 1 on the left, and I multiply by negative 1 on the right. And so that equation will become negative y equals negative 4x plus 2. And then if I add the 2 equations, y plus negative y is 0. 0.5x minus 4x is negative 3.5x. Plus 1.5 plus 2, that's plus 3.5. And then notice I can solve for x. So I add 3.5x. This will give me 3.5x equals 3.5. Divide by 3.5 and I get x equals 1. All right, now remember we have to find the point of intersection or points of intersection. Okay, so we found x. How do we find y? Well, we take either of the two original equations and substitute x equals 1. So I'm going to use the second equation that says y equals 4x minus 2. So y will equal 4x, but we have a number for x, minus 2. The number for x is 1, or the value of x is 1. So y equals 4 minus 2, so y equals 2. What is the point of intersection? 1, comma 2. Yeah? And notice, by the way, if I can find the answer, that means if I were to graph the two lines, they would look like so, something like that. Oh, in fact, this is the same. It's the same system of equations. Yeah? So we can see that we got the right answer. All right, let's try number 2. So number 2, I'm going to, again, use the elimination method. I'm going to multiply the top by 2 to get 12x and the bottom by 3 to get negative 12x. Notice I can do both of those. So I'll multiply the top by 2. Don't forget to multiply on both sides. And I'll get, I'll write it this way. This is 12x plus 6y equals negative 30. And then the bottom one I said by 3. By 3. And that'll give me negative 12x minus 6y equals 60. Okay, so when I add, well, 12x minus 12x is 0, 6y minus 6y is 0, so I have 0 on the left equals 30 on the right. Doesn't sound like good news, but in fact, it's okay. We still get information from that, okay? So anytime you get an equation where your variables disappear, but your numbers are not the same, or this is a contradiction, the answer is no solution. Notice this is the case, if we were to graph these two, that the lines are parallel, okay? What was the other one? This one over here, right, where the lines coincide. So in that case, your variables would disappear, but you would get the same number on both sides of the equal. Okay. So notice sometimes your variables will disappear. If your numbers don't agree, that means if it's a contradiction, then it's no solution. If there's the same number on both sides of the equal, then it's the infinitely many solutions. Yeah. And the only other thing that can happen is you can solve for x and y, which means there's a point of intersection. Let's try the third one. So the third one, I'm going to use substitution. Substitution method says we solve one equation for one variable and substitute in the other equation. So I'm going to solve the bottom equation for x. That means I need to add y. So it'll look like this. X equals y plus 2. Yeah? And then I'm going to take the other equation. And in this equation, I'm going to rewrite the equation, but I'm going to substitute for x a y plus 2. That means wherever I see x in that equation, I'll write y plus 2 instead. So 2x becomes 2 times y plus 2 minus 3y equals 5. Yeah, all I did was change the x to a y plus 2. All right, and then I'm going to solve. Notice I just have y now. So I'm going to distribute here first. That's 2y plus 4 minus 3y equals 5. The 2y and the minus 3y add up to negative y equals... if I subtract 4 from both sides, I get 1, right? Subtract 4. And so y will be then negative 1. Y equals negative 1. How do I find x? Well, I go back to this first equation here. And I just substitute the y, right? So my x is going to be, y is negative 1 plus 2. And so x is... make a little bit of room here, so x is 1. Okay, so the point of intersection then is 1 comma negative 1. Yeah? All right, notice I could have done that one by elimination. If I just multiplied the bottom by, let's say, negative 2, I could have canceled my, eliminated my x and solved for y. Okay, so I'm going to stop there. That's what we need to know. The part 1 is just substituting values for x and y in a function, right? So it's evaluating functions. We just plug in the values that they give us, and then 4, 5, and 6 will we'll do in class, and a couple of word problems that we'll do in class with a little bit of vocabulary. All right, so that's the end of section 6.1.